when we have exponents, and we've taken a look at this with polynomials as well, we can have variables with exponents. And then we can start putting those things together. We can start multiplying them together and dividing them and so on and so forth. And so we're going to take a look now at how those laws that we've looked at to start apply to variables as well. And then we're going to end off with some stuff with brackets and how we need to be careful about our brackets as well. So to start, a variable can be used instead, spell it right, can be used instead of a number. Okay, so we can always replace our numbers with variables if that number could be different. We can also replace our variables with numbers if we know which number it is. Now, the answer cannot be found unless the variable is known, but it can be simplified. We're not going to find what is x, or can we actually solve for x. No, but we can at least simplify to make it a little bit easier to use. And again, that'll go back to what we'll do later on in our questions. Maybe not so much in this course, but in the future, we'll looking at how do we simplify this to solve a question later on. So let's take a look at a few examples here. Here we have x as our base, and then we have the exponent 2 and the exponent 4. Now, just like any of the other questions that we've done, because they're multiplying together and have the same base, we can add the exponents together. And we're going to get a value of 6 right there. So if we add, because they're multiplying, we add the exponents together, and this is going to give us a new power, or a simplified power, of x to the power of 6. We have x squared and x to the power of 4, and so that answer is x to the power of 6. In the same way, when we see dividing, we're going to do exactly like we would with dividing the other ones. Okay, so we're actually going to take the top, because they have the same base, again, very important, same base. With the same base, we're going to take the top one, and we're going to subtract the bottom exponent to come up with a new exponent. Now, that is going to give us a new power, where we have still the same base, but now we have a new exponent, which has gone through the dividing stage. Okay, so c to the power of 6 divided by c to the power of 4 is the same as c to the power of 2, or c squared. Whoops, there we go. Okay, same thing with brackets. Now we have v as our base, and we have v to the power of 3, and then the whole thing is going to the power of 4. So we can take that and do our quick little multiplication here. 3 times 4 is equal to 12. So that tells us that the answer to this question, or sorry, the simplified version of this question, is technically not, I guess, an answer, but it is the simplified version, is v to the power of 12. Okay, it's v to the power of 12. Okay, here's another example. Okay, now we have a monomial in here of ab, so it's a times b. What's going to happen here is we're going to take this 4 and we're going to apply it to the a, and we're also going to apply it to the b. So to simplify it, we're going to apply it to both. Now, both of them right now have an exponent of 1, so it's going to be 4 times 1 and 4 times 1, okay? Which isn't overly difficult. 4 times 1 is 1. So when we multiply this up, or we put it all together, this is going to be a to the power of 4 and b to the power of 4, and this is going to be our new monomial. There's 4 a's, 4 b's, okay, put together in one multiplication statement. Okay, it's because there's a 4 on the outside, so there is 4ab, or ab to the power of 4, which is the same as a to the power of 4 and b to the power of 4. In this case here, we have another one where where we have h cubed I with a 3 on the outside. So that means that this 3 is going to go to the h cubed, and it's going to go to the I to the power of 1. Okay, now I to the power of 1 has an exponent of 1. So when we multiply these together here, 3 times 3 is h to the power of 9, and 3 times 1 is I to the power of 3. That's going to be our new monomial. Now again, the exponents don't have to be the same, but there are multiplied from there. Okay. Now, So that's how we bring that inside those brackets, and we can just use it with our variables as well. Now, with a monomial inside the brackets, the exponent, and this is kind of what we started going through here, will be applied to each part of the monomial. Okay, so just like we did here, we took this and we multiplied each part of the monomial. If we have a number in there, then we're going to apply it to the number as well. So this 2 is going to apply to the 2, and it's going to apply to the a. So we do both of them. So a little bit in there. Okay. Now we can do this in a couple different ways. We could do 2 squared a squared. We could do that, or we know that. Let's actually do that. Let's do 2 squared and a squared. Now, if I asked you to evaluate this here, evaluate just means to kind of come up with our answer. 2 squared is the same as 4, and so this is just then 4a squared. So we can actually do the calculation. If I ask you to evaluate, or if I ask you to simplify completely, this would be our final simplification. Again, I'm not usually asking you to do that, but you could do that if you wanted. The next one is a little more difficult to do that, especially since we have a bigger power on the outside. But in this case, we have a 4 being applied to all of the pieces in that inside the bracket. So the 4 is being applied to the y, it's being applied to the 2 or the x squared, and it's being applied to the 5. So when we do this, let's apply it to each piece. We're going to have 5 to the power of 4, and then now we have x squared and to the power of 4, so that's 2 times 4 is 8, so it's x to the power of 8, and y is to the power of 1 originally, and so we're just going to multiply it by 4, and so it's y to the power of 4. Now, this is exactly what we do. It's applied to each piece, but we can also find what 5 to the power of 4 is. Okay, and it is 625, and then we have our variables afterwards. So we can do that as well. That is what 5 to the power of 4 is. You can use a calculator for that. It's 5 times 5 times 5 times 5. Okay, 5 times 5 is 25, times another 5 is 125, times another 5 is 625. So that's how this law applies to our values. Now, the law only applies to monomials inside the brackets. If there are multiple terms, such as like a polynomial inside the brackets, they, oops, I need to spell that right there, monomials, okay, then they need to be applied first. Or they should actually be solved first. That should say solved first. Okay, they need to be solved first. So something like this here, okay, 6 minus 2 squared. Okay, I'm going to show you the wrong way how to do that first. Okay, and maybe that's not the best thing, but I'm going to show you the wrong way to do it first, and then I'm going to go through and show you the right way. So the wrong way, let's write this out again so we can mark it up a little bit. 6 minus 2 squared would be to think that it's the same as a monomial, and that all we're going to do is we're going to apply this 2 to both the 2 and the 6. Okay. Firstly, we'd be doing negative 2 squared, so that'd be actually positive 4. Okay, and so what we would actually end up getting, let's use red here. So that's what I use for marking up there. Okay, so if we apply that, we would then get, we could think of it as 6 squared minus 2 squared. Okay, kind of think of it like that, which would then be 36 minus 4. Technically, because this is a negative 2 we're applying to, it could change, but let's just say it's 36 minus 4, which is 32. If we did it the other way, it would be 40. Okay? Either way, it's going to be wrong. Okay? This is the wrong way. Applying it first, you cannot do that because these are, you need to solve inside the brackets first. The right way to do it, and I will show you right here. Okay? And so I'm going to rewrite out the original so I can mark it up again a little bit. Okay. The first thing that we always do whenever we see brackets is we try to combine what's inside the brackets first. In this case, 6 minus 2 is just 4. So what it becomes then, and I'll keep the brackets on there, but inside is going to be 4 to the power of 2. Okay. And this is, we know that this is just the same as 16, very different from 32, okay, or 40, okay, if we did it the other way. We need to solve inside the brackets first. So we can't just apply to each piece. We have to solve inside the brackets first and then go through with it. Okay. What? Yeah. So we'll just kind of leave it right there. Next year, if you take applied or pre-cal, you'll be looking at how this or what kind of effect this has on different polynomials. But for right now, let's just leave it with make sure that it is a monomial. All right, questions 4 and 5. Finish off the assignment. Make sure you have the entire assignment finished, and then make sure you hand it in as well.